Okay, today we're moving on to Unit 2, Notes 4, which is solving systems by elimination. So this is just another method to do kind of the same thing that we did yesterday. So here are the steps. If you want to go ahead, you can pause the video, at least get them written down, and then you can listen to me talk once you're finished. The first thing you want to do is make sure that both of your equations are in standard form, which means that your x's and y's are on one side, and your thing that's just a number, that constant, is on the other side. Then you're going to multiply one, or sometimes you have to multiply both of the equations by a number so that one of the variables has opposite coefficients. So we're looking for the same number with opposite signs. So you have to think logically about how you can make that happen. The next thing you should do is you're going to add the two equations together. And if you have same coefficients that are opposite, the variables should cancel. The next thing you want to do is solve for the remaining variable. You should only have one left, and then you can solve for that variable. The last thing you need to do is substitute that value into one of the equations and solve for the other variable. So you're going to substitute in, get your other variable, then you should have a coordinate point of 2 points. Just like what we talked about yesterday, the same thing can happen with elimination. You can sometimes have both your variables cancel, and what's left is a true statement. If you recall what we talked about yesterday, that means that there's infinitely many solutions. We also sometimes write that as IMS. The next thing, if both variables cancel and what is left is a false statement, then the system is said to have no solutions. So this only really applies if both of your variables cancel. So you need to kind of watch out for that as you're working through these problems. So let's go ahead and try some of these. So we look at step number 1, which is to put the equation in standard form. Well, that's already done for us. The next one wants us to multiply one or both equations by a number so that the variables have opposite coefficients. So I'm going to start, and I'm going to see if I have any with at least the same coefficients. So I look, and x, they both have a coefficient of 1. So I already have the same coefficient. I'm halfway there. Now I just need to make it opposite. So I'm going to take this first one, and I'm going to multiply it by a negative. So I'm going to take that negative, and I'm going to distribute it into each thing. And then I get a new system. I get x plus 2y is equal to 10. And then I get negative x minus y is equal to negative 6. Because I have the same coefficient and opposite signs, I can go ahead and add these two together. X minus x cancels out to 0. 2y minus y is going to give me a positive y. And then 10 minus 6 gives me 4. So now I know that y is equal to 4. Okay, just like I did yesterday, once I know one variable, I can plug it back in to get the other version. And just like yesterday, it doesn't matter which one I pick, they will all work. So let's just pick the first one. So I'm going to have x plus 2 times 4 is equal to 10. So now I want to go through and solve that for x. So instead of writing y, I wrote 4, and now I'm just simplifying it out to see what my x is equal to. I'm going to subtract 8 from both sides, and then I'm going to get x is equal to 2. So once I have my two answers, I can go ahead and write them as a coordinate point. So again, I went through that pretty quickly. If you're confused, rewatch it again. See if you can catch what's going on. All right, let's take a look at number 2. So again, when I'm starting this off, I want to look for things that have the same coefficients. Okay, it's already in standard form, and now I see that both of my y's have the same coefficient. They're both 1. So now all I have to do is make one of them opposite. So I'm going to take and I'm going to make this one a negative. Remember to make sure you distribute that negative all the way to the other side of the equal sign. That entire equation is changing. Okay, that being said, when you change it to being negative, if you change everything to being negative, you're not changing the value of the problem. Okay, it's still the same thing. It's just looking a little bit different. I like to say it's kind of like a hairdo. Okay, you wear your hair straight one day, you wear it curly the next day. It's the same hair. It's just going to look a little different. It still means the same thing. So we're going to go ahead and add these two together. So I have 2x minus 3x, which gives me negative 8. My y's are going to, or sorry, negative x. My y's are going to cancel to 0. 4 minus 8 is going to give me a negative 4. So now I have negative x is equal to a negative 4. Well, I don't want to know what negative x is. I want to know what x is. So I'm going to divide both sides by a negative 1, and then I get x is equal to a positive 4. Once I know that, I can go ahead and plug that back into one of the original problems to get my y. So I'm just going to pick one. It doesn't matter which one I pick. So I'm going to pick the first one. So instead of writing x, I'm writing 4. So then I get 8 plus y is equal to 4. I'm going to subtract 8 from both sides. And then I get y is equal to a negative 4. After that, I can write out my coordinate points. So I have positive 4 and a negative 4. Let's keep practicing. So take a look at this one first. Ask yourself, is it in standard form? Which it is. Okay, so now we can go ahead and move on to the next step. The next step is getting the same coefficient with opposite signs. So we need to multiply something. Now, when I say things like making it negative, what I'm doing is just multiplying the entire thing by a negative 1. So I look and I see that x has the same coefficient. They both have a coefficient of 2. And now I need to make it opposite. So I'm going to pick an equation. It doesn't matter which one. And I'm going to make it opposite. So I'm going to take that negative 1 and distribute it into everything, including what's on the other side of the equal sign, making it negative or changing the signs. So when I do that, I get this equation that stays the same, and then this second equation is going to switch all of the signs because I made it opposite by multiplying that negative 1. So now I can go through and add them. 2x minus 2x is going to be 0. And then negative 3y minus 2y is negative 5y. And 11 minus 6 is 5. So now I have negative 5y is equal to 5. So I'm going to divide both sides by negative 5. And I get that y is equal to negative 1. Step 1, done. Now I just need to see what x is equal to. So what I'm going to do is I'm going to just going to plug that back in. Again, doesn't matter which equation. I just picked the first one because it's first. So I'm going to plug in a negative 1 instead of writing my y because I know y is equal to a negative 1. So then I get 2x plus 3 is equal to 11. Subtract 3 from both sides. And then I get 2x is equal to 8. Divide both sides by 2. And I get x is equal to 4. So then I can go ahead and write out the coordinate point that is the solution for this, which is 4, negative 1. Your x comes first, your y comes second when you're writing out those points. Take a look at number 4. Ask yourself, is it in standard form? It is. And actually, we already have same coefficients that are opposite. You can see that on there. So really, you can go straight ahead and you can add these two together and those y's will eliminate. So I want you to pause the video and practice this one on your own right now. Again, you can go straight to adding them together because you already have those coefficients that are the same and opposite. All right, let's take a look at one of these. So this is the first time that step number 1 doesn't hold true for us. Okay, so what we need to do is I need to think of something I can, first of all, I need to get this second one here in standard form. So I have 2x is equal to 8 minus y. Well, in order to get that in standard form, I need my x's and y's on the same side. So I'm going to add y to both sides. And then I get 2x plus y is equal to 8. So I'm going to go ahead and line that up with my, that's hard to see, line that up with my other equation. So the first equation stayed the same. And the second equation we changed to be a little different. So now I have to multiply. I don't have coefficients that are the same. So I have to think of a number I can multiply to get opposites. Well, I see that this y here has a positive coefficient of 1. That makes multiplying to an opposite pretty straightforward. So we want to multiply to a 3, and we also want to have a negative 3. So in order to get a negative 3, I can multiply this whole thing by a negative 3. So that's going to change up our system a little bit. So here's our new system. The first one's going to stay the same. And then the next one is going to multiply. And we're going to get this. When we distribute that negative 3 into each term. So now we can go ahead and add them together. 6x minus 6x is 0. 3y minus 3y is 0. 12 minus 24 is negative 12. Well, now I get that 0 equals negative 12. Both my variables cancel. So that's why I want to reference back that chart. Okay, if the variables cancel and what is left is a false statement, that means there is no solution. Okay, so this is a false statement. 0 will never equal negative 12. I'm going to have you try most of number 6. Okay, it's already in standard form. Think about how this is a 1y. So there's a 1 in front of that y. Okay, so we want to get it to be the opposite of 6. So I want you to figure out how you can make that 1 right there a negative 6. So pause the video, think about it. Okay, all you have to do is multiply this by a negative 6. Okay, so I want you to do that, and then I want you to add the two together and see what happens. I'll give you a hint so you know you're in the right direction. It's either going to work out that there's no solution or infinitely many solutions. Okay, so when you multiply them by 6, add them together, one of those two things should happen. Let's take a look at some word problems. Remember when we're writing word problems, a lot of times we put them into standard form. Okay, so Dante spent $11.25 on 3 new and 4 old comic books. So what I'm going to do is I'm going to let X equal new comic books, and I'm going to let Y equal old comic books. So for $11.25, he bought 3 new and 4 old. Okay, Samantha spent $15.75. So for $15.75, she got 10 old and 3 new. So now we want to figure out how much each of them cost. X is representing the cost of new, Y is representing the cost of old. So I look, and this is in standard form. When things are in standard form, it's a lot easier to use elimination. And I look at these X's, and I see that they have the same coefficients. So I'm going to go ahead and I'm going to make this opposite. So I'm going to multiply in a negative 1 and change the sign of everything in there. So then I get 3x plus 4y is equal to 11.25. And then I get negative 3x minus 10y is equal to a negative 15.75. And I can go ahead and I can add those two together. When I do that, these x's cancel. 4y minus 10y is negative 6y. 11.25 minus 15.75 is negative 4.5. So then I'm going to divide both sides by negative 6. And I get y is equal to 75 cents. And I want to make sure I know that that's for old comic books. So now that I've done that, I need to plug that back in to get my x. So I plug that back in. I'm going to get 3x 4 times 0.75 is equal to 11.25. So simplifying that out, I get 3x plus 3 is equal to 11.25. Subtract both 3 from both sides, and I get 8.25. Divide both sides by 3, and I get that x is equal to $2.75 for new comic books. So make sure you tell the difference between those two. Let's take a look at another word problem here. So the sum of two numbers is 12. So we're going to let the difference between each of those numbers be x and y. So we're going to get x plus y is equal to 12. And then the difference, x minus y, is equal to negative 4. So this is set up really nicely for you to use elimination. I want you to go ahead and do that on your own. Solve that one by elimination for me. Next one. Again, let's set this up and have you solve it. So here are the two equations. Okay, go ahead and pause it if you need to read it. So we want to figure out when they're going to be in the same place. So we have 3y is equal to 6x plus 6. Oh, you can't see that. 3y is equal to 6x plus 6. And then you have negative 2x plus y is equal to 3. So we need to get those to be in the same place. You need to put it into standard form. Okay, putting it in standard form, you get negative 6x plus 3y is equal to 6. Negative 2x plus y is equal to 3. So go ahead and solve that one by elimination for me. You're going to have to create your opposites. Okay, that's my hint to you. Lastly, I want you to try setting up this word problem on your own. It's set up similarly to number 10. So use that and make sure you take your quiz once you're done.